Hey guys, welcome back to Polynomials. In this video we're going to be solving some derivatives. If this is a new topic for you, I suggest watching Carter's video where he goes over derivatives. It's pretty important to understand this video. If not, that's fine, and we'll jump right into it. The first thing we're going to look at are polynomials when taking a derivative. In this case we'll use 5x squared plus 10x plus 15. Now, due to linearity, we can rewrite this to be 5 times d over dx of x squared plus 10 d dx times x plus 15 d dx times 1. Now, the derivative of x squared is equivalent to 2x. Derivative of x is equivalent to 1, and the derivative of any constant value, so including 1, is equivalent to 0. Now plug these in. Now you get 5 times 2x plus 10 times 1 plus 15 times 0. Now this will go away, and that will be equivalent to 10x plus 10. Next, we'll look at the product rule. This is useful whenever two functions are being multiplied together. In this case, we're going to use natural log of x multiplied by cosine of x. Now, the derivative of natural log of x is equal to 1 over x. And the derivative of cosine of x is equivalent to negative sine of x. Now, the way you do product rule is you take the derivative of the first function, multiply it by the second function, and then add the first function and multiply it by the derivative of the second function. So that would be 1 over x multiplied by cosine of x plus natural log of x times negative sine of x. Now, it can be written as this. The third thing we will look at is the quotient rule. The quotient rule is very useful when two functions are being divided. In this video, we will be using the quotient rule to prove that the derivative of tangent of x is equivalent to the secant squared of x. Now, remember that you can rewrite tangent of x to be d over dx sine of x over cosine of x, which will allow us to use the quotient rule on it. Now, the quotient rule is taking the denominator, in this case g of x, multiplying it by the derivative of the numerator minus the numerator, multiplying it by the derivative of the denominator, all over the denominator squared. Now, an easy way to remember this is by saying low d high, that's in low multiplied by derivative of high, minus high d low, or high times the derivative of the low, over the low squared. So we can apply that here. Remember that derivative of sine x is equivalent to cosine of x, and that the derivative of cosine of x is equivalent to negative sine of x. Now, plugging these into this equation right here for the quotient rule, we can get that this is equivalent to cosine of x times cosine of x minus sine of x times negative sine of x over cosine squared x. Now this can be rewritten as cosine squared x plus sine squared x over cosine squared x. Now remember that cosine squared of x plus sine squared of x is equivalent to 1. So that is also equivalent to 1 over cosine squared of x. Now 1 over cosine squared of x is equivalent to secant squared of x, which is what we set out to prove. The fourth thing we will look at is the chain rule. Now, a chain rule is useful whenever there's a function within a function. So the notation for this one is whenever you take the derivative of y of g of x is equivalent to y prime g of x times g prime of x. Now, in this situation, we will look at 5 times e to the power of sine x. Now, for this notation, we would have y of x be equivalent to e to the power of x, and g of x is equivalent to sine of x. So now we go and look for y prime of x, right? Y prime of x. Now that's d over dx of ex, e to the power of x, and that is equivalent to e to the power of x. Now g prime of x is d over dx of sine x, which is equivalent to cosine of x. Now, we can rewrite this problem to be 5 e over dx of e sine x because of linearity. Now, if we use this to plug into this equation up here, we can see that y prime of g, which would be right here, and plugging in this sine of x into that x right there. So that'd be e to the power of sine x multiplied by g prime, which is cosine of x. All multiplied by 5. So the answer is 5 cosine x e power of sine x. These are some of the more common problems you'll see when dealing with derivatives. If you have any questions, comment them down below. If you enjoyed the content, like and subscribe. Thanks for watching.